Hey, what's up, everybody? Welcome back. We finally made it to the very last day of volume, so we're only going to do 5 different types. This last one, as you probably have guessed already, we need to revolve around vertical lines that are not the y-axis. We'll just do one example today that I already have set up. So first we need to figure out the region we're talking about. So I've already drawn y equals 2/3 x equals 0, and y equals 2. That means we're talking about this region here. This is the only region that is bounded by all 3 of those things that I just mentioned. And then the vertical line that we're going to revolve around is x equals 4, which is somewhere out here. It matters where it is, so I think the very first thing that we should work on is figuring out where this intersect point is. Just like we always do, we would take the 2 different equations and set them equal to each other. So one of them's y equals 2, so I'm going to take 2 and set it equal to 2/3 x. And I think that maybe I want to save room for my graph, so let's maybe move this down here. Okay, and like we've always done, we can either solve this by hand or actually graph these in our calculator and find the solution, but we would end up with an x equals 3. So we know that this part right here is 3, which helps us to know that x equals 4 would be a vertical line out here someplace that I'm going to draw in. Okay, so if we have this shape that's kind of over here and then we have this line, we're going to need to draw it by reflecting it over this way. So I'm going to take our key points, which is right here. Let's change the color back so it matches. So we have this distance, we'd have this other intersect right here, and then we have this amount here would take us way out here someplace. We'd have this vertical line which would end up over here. So our region would look something like this when we reflect it over. So it looks like we're going to have, again, if this was our region revolved around this way, so we're revolving this way this time, so that's the way our circle should go. They should be centered on this line x equals 4 right here. Looks very much like then a washer problem where we're going to have some sort of hollow center, and then we have, each time we'd have some sort of larger solid circle. So one thing we should keep in mind then is if our circles are going this way, that to create our volume we're going to need to sum them up this way, which means that we're going to be using y's in this problem. Maybe I'll go ahead and set that part up then. If it's a washer problem, it's going to be pi r squared minus pi r squared again. But we said that we're going to be using y's this time, so I need to figure out where I need to start and stop. Well, it looks like our region starts at a y value of 0 here and ends at a y value of 2. So I can go ahead and fill in a 0 and a 2 here. Okay, I think the trickiest part of this problem is figuring out where to draw a representative radius, or in this case, radii. Let's stick to the convention like what we did in day 4. We said if we took our shape and reflected it up to draw it, that we should draw our radius going in the opposite direction. The same thing holds true for these ones around vertical lines. So we reflected to the right, so I think it makes it easier to visualize if we go ahead and draw our radius the opposite direction, which would be to the left. So from our center here, what I'm going to call r sub 2 in inner radius would really be this amount. And then we would have our outer one would start at that same vertical line and would draw out to here. And a really interesting thing in this problem is it looks like no matter where our circles were, our radius would go from this x equals 4. The outside part would always hit the y-axis right here, so that's kind of interesting. In fact, it makes that part a whole lot easier. No matter where it's at, if what I'm going to call r sub 1 always starts here until we hit the y-axis, well, that has to be a distance of 4 every single time. So our r sub 1 is just going to be a constant 4. Not always going to be for all these vertical line ones, but our drawing will show us how to do. Typically, most of the time, we'll end up with more of a situation like what we see with r sub 2. And what I would ask you to keep in mind is remember that distances on a coordinate axis or on a coordinate graph should start at some sort of axis, the x or the y. So the thing that we know starting at the y-axis is here. So the distance from this to here is due to this function. But we really need to know the absence of that, so everything else. That's what r sub 2 is. So much like what we did in the last example, day 4 together, we're going to have to look at this full amount here. This full amount we've already talked about is 4. So we need to take this full amount of 4 and we need to subtract out this little piece. Well, I think you know where we're headed in with this. If we need to have only variables of y's, then we need to solve this one for x here. And this one's pretty easy to solve for x. We would just multiply by the reciprocal of this. So we could have x equals 3/2 y. So our r sub 2 needs to be the full amount of 4, and we need to subtract out this little piece, which is this expression here of 3/2 y. And that's really all we need to do to figure this part out. Our outer radius was r sub 1, so that would be a 4 squared. We need to subtract the inner radius squared, so that'd be a 4 minus 3/2 y squared. And make sure we get our notation straight. It would be dy this time. Okay, make sure this matches. We have, these are in terms of y's, we have pi r squared minus pi r squared. So that's all we really need. Pull up our calculator. I still have it kind of set up from the day 4, so I'm just going to change this outer one is a 4. And remember, our calculator doesn't know any better, so I'll just type these in with x's. So I'm going to type in 4 minus 3/2 is the same as 1.5. And I'm going to put it in as an x. So now when I go to the home screen, it looks like I'm going to need to cut and paste again, so second enter and then second enter. Let's see, do I have it set up still? We have outer radius squared minus inner radius squared. X looks like I need to change because we're going from 0 to 2. So 0, comma 2. Hit enter. Very interesting, we get an exact answer of 18. So it looks like our volume is just 18 pi. Okay, so that's the one and only example we'll do from day 5. Please definitely by this point, if you're still having trouble with volumes, it's one of those things, once you catch on to it, it makes it way easier because it really is just a bunch of circles that we're adding up. But until you catch on to it, it does seem like one of the most difficult things in the world. Please come in, let's talk if you're still having trouble with any of the days. I'm happy to help you, and of course you're getting lots of practice through the different classwork or homework assignments we're doing. Alright, I think that's it for volumes. I'll see you all real soon. Have a great rest of your day. McMaster out.